Hi, this is Serena Shejala. Welcome to ECP Tech. Today in this class we are going to learn about another important routing algorithm is hierarchical routing algorithm. See, in the previous classes we see different type of routing algorithms, nothing but an shortest path routing algorithm, Dijkstra's routing algorithm, as well as flooding routing algorithm. So one of the most efficient routing algorithm for larger networks is an hierarchical routing algorithm. Let us get into the topic. What is meant by hierarchical routing algorithm? How it will be implemented in the network? How the data packets are passed from source to destination, right? So hierarchical routing algorithm. Hierarchical routing algorithm. See, in this routing algorithm, the routers are divided into regions. The routers are divided into regions. In other words, we can say this regions is nothing but an clusters. These regions is nothing but an clusters. Here, each router has a complete details about how the packets can pass from source to destination with its own reason. Means if two or more routers combine into one region, so if you want to deliver one packet from source to destination, right, within one region we have a source and destination. We can deliver a packet from source to destination in particular one region, so it has a complete details about all how the route packets to destination with its own reason. Okay, so here if you want to send a data packet from one region to another region means if one router of one region to another router of another region, here there is no information and there is no idea about another region routing structure, right? So that is the main thing. Here each and every routers are divided into regions. Each and every router is divided into regions. Okay, we will see the example how the routers become and regions or the clusters. How can we can communicate or we can pass or we can deliver the data packet from one region to the another region, right? See here the what is the main thing of an hierarchical routing is why it is implemented means we have a link state algorithm and distance vector algorithm, unicast algorithms. We can call it as that is an unicast algorithms. Here in this type of algorithms, every router maintains some information about all other routers wherever the packet is going from one place to another place in the network. So whenever the routers will be increased, the network will also be increased. The routers will increase, the network will also be increased. Therefore, the size of the routing table also increases. So here, the routers maintain the details and information about the packets and the routes and the devices. They will maintain an one routing table, right? So whenever the routers increases as well as the network will also increase, at the same time the size of the routing table also increases. See, for the larger type of networks, it is quite difficult to handle. It is quite difficult to handle. So for this reason, whenever we are performing or we are passing one packet from source to destination in a larger type of network efficiently, so hierarchical routing is using. So this hierarchical routing reduces the network traffic. Okay, so it will reduce the difficulty of handling these type of such problems means network here root whenever the routing table increases as well as we can find there is a much difficult to find the particular hope from one reason to the another reason. There are a lot of problems will be there. So these kind of problems will be resolved by using this hierarchical routing algorithm, right? So let us consider one example how we can simplify this particular routing table into smaller hierarchical routing table, right? So let us take one example how the routers or grouped into the one type of regions or the clusters. How can we communicate from one cluster to another cluster? Okay, so let us take one example here. So this is an example. So this is an example. See here, we have a four reasons: reason 1, reason 2, reason 3, and reason 4, right? Okay, so this is an one router. I already said the routers will be divided into reasons, or we can say this is an one type of cluster, right? So here these are the devices or hopes. These are the devices or hopes, right? Here the reason one means so these three hopes maintain one type of router, and these hopes are maintain one type of router. Okay, right? So how can we communicate? Here the each and every reason maintain or every router maintain the information or the maintain all the particular details about this type of host within this region. So it will maintain a region, it will maintain a hopes of A, B, C of this particular region, right? So it doesn't have no idea about the what is the network structure of a second router, internal structure of the second router, right? Here we are connecting from one region to another region by using some paths. See here. So this is an actual diagram, right? So if we are maintaining and one type of table for these reasons, one type of table for these reasons. Okay. See, this is an routing table. So in this, we have a three slots. In this, we have a three slots. The first one means destination, and the second one link, and third one hop, right? So the first part means destination, the second one link, and third one hop means it's nothing but an, we can call it, this is an node or device, node or device, right? So I'm writing destination, link means so the connection between one hop to another, link, and the hop or node, right? Okay, so here uh, here we will see the what is each and every node. We have to write an routing table here. We have to write an routing table. So the first one, so here these three nodes will be in the region 1. So I am call it is, this is an 1A, 1B, 1C. So find out where the interlinked nodes from these three nodes, where the interlinked nodes to the other regions of these three nodes. Okay, so 1A, first I am writing for 1A. So 1A, there is no interlinked connection, so there is no link. Okay, next. So 1B, there is a connection of another region. Okay, second region there is an one connection, only one connection. So 1B, so link coming from, see, observe this diagram very clearly, link coming from 1B, where it coming from I will writing 1B. So how many devices are connected? Only one device. Next, like that 1C. Okay, reason 1, 1C, 1C. So it also connected to the another node of another region. Okay, region 3. So the links coming from an C onwards. So I am writing the link 1C. So how many nodes are connected to another regions? One node. Direct connection is one node. Right? Oops. 1. Okay. So this is a first region or first router information. Router 1 information. Next, kindly check for the second region. So we have a we have a 4 nodes A, B, C, D, 4 nodes in the second reason. So this is a reason 2. So I am calling this is an 2A, 2B, 2C, 2D, right? Okay. So just 2A, how many nodes are connected? So it will be connected by, interlinked by 1B. So 2A, the first one. So it was interlinked by 1B. So write that 1B. So how many nodes are connected? 1, 2. 2 nodes are connected here. From 2A, 2 nodes are connected. Okay. 2 nodes are connected. Right. Next, 2B. So like that, each and every router we have to maintain one type of where it goes from, where it interlinked to the next region, next devices. We have to write for each and every node for routing table, right? So this is a full routing table. Full routing table. So this will be summarized into hierarchical routing table from 2B. So it is coming from an 1B, the link coming from an 1B. How many nodes are connected here from 2B? 3 nodes, right? Again 2C. So this is also from 1B. How many nodes are connected? Just see, 1, 2, 3, 3 nodes, right? Next, 2D. It also coming from 1B. How many nodes are connected? 4. 1, 2, 3, 4. 1, 2, 3, 4 nodes. Right. So this is the information of a second reason. Reason 2. Right. So like that we also write and this type of table, this routing table for reason 3, reason 4 also. So let us check that also. Okay. The first one, destination, link, or we can call it as line, hope, or node. Right. So 1, 2 reasons I wrote and routing table for 1, 2 reason. For third reason, okay. So 3A is a direct connection from 1C. 3A link from 1C, right? Okay. How many nodes are connected? 3 nodes. 3 nodes. C from 1, 2, 3. 3 nodes. Okay. Next 3B. It is from 1C, 2 nodes. Only 2 nodes. C. 1C, 2 nodes. So this is a third reason. So I can write these nodes as 3A, 3B. Right? Okay. Next, reason 4. This is the information about reason 3 or cluster 3. We can call it as cluster 3. Reason 3. Right? So next, 4. 4A is coming from 1C. Okay. So how many nodes are connected? So 4A means 4A, 4B, 4C. So these are connected in the reason 4. That's why I'm writing 4A, 4B, 4C. Okay. I think it is clear. So just to check how many nodes are connected from 1C. 1, 2, 3. Okay. 3 nodes. Next. 4B. 4B, it's a direct connection from an 1B. See? So from 1B onwards, it comes an direct connection from D, right? So 1B, How many nodes are connected means 4. See, I think 1, 1, 2, 3, 4. Okay, 4 nodes. Next, 1C also, 4C is coming from 1C. See, 1, 2, 3, 4. This is also an 4 nodes. So these are the here. This is one type of network. So this is a network structure, right? I connected and 4 routers, and each and every router contains an 3 or 4 systems that will be connected 3 or 4 systems. You can consider this is an one type of network. So for every router we have to write a routing table here. So this is an routing table. So this is too difficult to handle to verify the particular source and the destination in this routing table. Okay, this is a reason for. So this is a long routing table. This will be summarized into hierarchical routing table. So let us see the hierarchical routing table. How will be hierarchical routing table? So what is the difference we are seeing here? The first one, destination. Next, link and hope, or we can call it as node, right? Okay. So in the first routing table, so only 1B, 1C, 1C. The minimum thing we have to see, minimum number of host, minimum number of hope or nodes. So these are the minimum. In the first reason, so only one hope is there. This is the minimum nodes. Here, that particular one node to one node connected here. Only one node is connected. So that I wrote this particular thing into the hierarchical routing table. So let us go for a second reason. In this, see the minimum number of nodes which will be connected. Here, the minimum number of nodes is connected to 2A. So we can take this is an one path or the shortest path. For second reason, it's coming from 1B, 2 nodes are connected. So this is an shortest path to deliver our packets. So this is a very easy to identify the particular source and a destination in the routing table. How the packet is transferring from one place to the another place. That is the main thing of a hierarchical routing. So let us take that is reason 3. Sorry. Okay, reason 3. 3A, 3B. So find the minimum. 3B is coming from 1C to. So reason 3, 1C. 2 number of hosts. Next, at the same time, the reason 4, minimum 3. Okay. Fourth reason is coming from where it's come from? 1C. 1C, C, 3. So this is a hierarchical routing table. This is an hierarchical routing table. See, this is a one type of large network. So we wrote all the nodes, paths and destination, where it was linked, where it's come from, where it is linked to. So these all will be stored in the full routing table, right? So that will be summarized into hierarchical routing table. I take the minimum number of nodes where it connected. Minimum number of nodes where it connected, right? So that will be act as an shortest path to deliver our packet from one region to another region, and this is an final routing table. This is an final routing table. So it reduces the network traffic, and we can deliver the packet in the network very efficiently. So this particular routing table handles this type of problems, and this is about an hierarchical routing table. And let us see, we also have the advantages of a hierarchical routing table. So the biggest advantage of hierarchical routing table is scalability. Okay, so it's suitable for very large network, because for large network we have the routing table will be increased. Whenever the routers will be increased, the routing table will be increased. It was slight confused how the packet, where the packet comes from, and it will go to which node. So to reduce the type of confusion and network traffic, so this hierarchical routing is introduced for a very large network. And the second one is the routing state information can be aggregated to decrease the burden of the routing updates and storage. Whenever the point updates, always the routing table will be updated. Here it is also slight difficult to update that large routing table. So these two things are reduced. These two things are eliminated by using this hierarchical routing algorithm. Okay, so this is about an hierarchical routing algorithm, and we can discuss the different type of broadcast routing algorithm and distance vector routing algorithm in the next videos. I hope you understand, right? So kindly like, share, subscribe Easy BTech for more videos. Thank you.